So children, now today we will discuss about the sound in comparison with light. In comparison with light. Okay, children. Why you are comparing light with sound, sir? You may get out because both are same forms of energy. Sound is also a form of energy. Light is also a form of energy, and so many other forms are also there. Heat is a form of energy. We discussed, no? Potential energy is there, kinetic energy is there, muscular energy is there. I want to discuss sound and light. Basic difference: sound travels with a speed of 330 meters per second. 330 meters, it will go in 1 second. Speed of the sound. In air I'm talking. In air, because sound cannot travel in vacuum. Light will go at the speed of 3 into 10 to the power of 8 meters per second. Means approximately 1, 2, 3, 4, 5, 6, 7, 8 meters per second. See, speed of sound is somewhere around 300. Imagine 300. This is how much? 1, 2, 3. See, this much is there, almost. Okay, so we can say 1, 2, 3, 3,000 lakhs meters per second light travels. This is just 300 meters per second approximately. Actually 330 or 340 they will give. Different books will mention different, no problem children. Between 330 and 340 it will be there. That's not important. You just what I want to show you here is, my intention is to see the difference. This is so much fast, this is so much slowly. Sound is traveling very, very slow, just 330 meters per second, but this will travel 3,000 lakhs meters in 1 second. Oh, light is very fast. Okay, children. Sound cannot travel in vacuum. Cannot travel in vacuum. Okay, whereas light can travel in vacuum. Light can. If light can't travel in vacuum, how can you expect sunlight to reach the earth? Okay, sunlight is coming to earth, no children. Through the vacuum, through the space only it is coming. No. Yes, so light can travel in vacuum. Sound cannot travel in vacuum. Okay, sound cannot travel in vacuum. To do this, we have studied so many activities in lower classes. Again, I am telling a small activity. I hope all of you remembered bell jar experiment. Bell jar, please mute your audio, children. I hope you remember bell jar experiment, children. In bell jar experiment, what did we study? We kept here a bell, alarm bell, and here we kept a vacuum pump. By using this alarm bell is ringing. Alarm bell is ringing. When it is ringing, you will remove all the air using vacuum pump. And initially you can hear sound when there is air. When you remove full air and airtight you make it, this will be ringing, but you can't hear. Why? Because sound requires medium to travel. Sound requires medium to travel. Okay, children? That's why these are called, because it require medium. Sound require medium to travel. Sound require medium to travel. That's why they are called mechanical waves. They are called sound waves are called mechanical waves. Why they are called mechanical waves? They require medium. They require some particles to be there. Because when I'm talking, one particle will go and hit another particle. One particle will go and hit another particle. Like that, sound travels. Okay, this will go and give the sound to this will go and give and come back, this will go and give and come back, like that. To and from motion will be there, and sound travels using molecules. But light waves don't require medium. Light waves don't require medium to travel. That's why they are called as electromagnetic waves. They are called what, children? Electromagnetic waves. Once if I say, if people don't understand, man, I told you to mute your audios when I'm telling. So light, it don't require medium to travel. Such waves are called electromagnetic waves. Okay, and sound speed is almost 330. Light wave speed is 3 into 10. Sound cannot travel in vacuum. Light can travel in vacuum. Sound require medium, and light doesn't require any medium. And if you see the waves also, children, waves also, if you see, sound waves are longitudinal waves. Sound waves are longitudinal waves. And light waves are transverse waves. Transverse wave. These are if I ask in the exam, what is the difference between sound and light? 1, 2, 3, 4, all these differences you should write inside the exam. Okay, so sound travels in the form of longitudinal waves, and light travels in the form of transverse waves. Longitude transverse waves means will be like this, children. Transverse waves, they will be like this. These are called transverse waves. Okay, children, these are called transverse waves. Whereas longitudinal waves will be like this. Waves like this. This is longitudinal waves. Okay, children. Transverse waves, these waves are there, no children? They travel perpendicular to the medium and they travel parallel to the medium. Longitudinal waves travel parallel to medium. Transverse waves will travel perpendicular to medium. Okay, children? One difference, two difference, three difference, four difference, figure five difference. Five differences you should write in Sunday exam, 5 marks. Children. Okay, so the elevations are called crest. The elevations are called what? Crest. And the depressions are called trough. Light lesson you don't have officially in 9th class and 8th class. Children, light lesson you have official. Oh, in 8th class you have light lesson. Yeah, in 8th class you have light lesson, and 9th class and 8th class both have sound lesson. But light lesson in depth in 10th class you'll be having. But 8th class people you have light lesson, children, and 8th class and 9th class both have sound lesson, children. So please try to understand, children. The elevations are called crests and depressions are called trough. Elevations are called crest and depressions are called trough. Elevations are called crest, depressions are called trough. Okay, so in the same way, when molecules are coming together, they are called compressions. What they are called? Compression. Molecules are compressed. When molecules are going far, they are called rarefactions. Rarefactions. These are called compressions. These are called rarefactions. These are called compressions. These are called rarefactions. Compressions and rarefactions. So this is how longitudinal waves travels, children. How waves will come near, go far. Come near, go far. Come near, go far. Like that they will go, children. So five differences. 1, 2, 3, 4, 5. The diagram also you should draw. And in the diagram you have to mention crest and trough. In this diagram, compressions and rarefactions you have to mention. If you don't mention compressions and rarefactions, I will not give mark. Five differences, please all of you copy down. This is the topic for today, children, and I will send the videos, children. In the video description, link will be there. In that 10 questions will be there. Do that 10 questions also as a homework, and this difference also you write 5 times and send it to me, children. Okay, so this is today's class in sound lesson.